Right. All right, folks. Welcome to the March meetup. Hopefully, I'll be giving you a news roundup later. It'll be fairly short this month. I've been pretty hectic in the last few days in particular. So sorry about the disorganization with the meetup update and so on. Thank you for making it despite all of that. I guess one of the bigger news of the last month was the OpenMV updates. So for those that haven't used OpenMV or aren't aware of the project, it's been a long-running project. I think almost as long as MicroPython's been around. So the OpenMV project is designed to have MicroPython control the camera and allow you to do OpenCV-like sort of operations in a much easier way because it's MicroPython. It's quite a mature project now. There's an IDE that they've built as well, so that there's some really neat features where you can have the stream coming from the camera straight through to your computer, and you can do like a lot of your filtering live as the application runs. You can do things like face tracking, blob detection, color detection, barcode interpretation, all from the camera. It's a really interesting project in its own right. This latest Kickstarter, they've gone through a couple of Kickstarters in the past. This one's designed to release these two cameras based on some really interesting microcontrollers, the STM32N6 and the ALIF AE3, the Ensemble AE3. The interesting part about those micros is they've both got quite impressive hardware acceleration for machine learning algorithms, which is super useful for when you're doing video processing. So they've got some really hugely improved algorithms on these devices from the looks of it. And the other advantage is, I guess, of the ALIF one is it's quite small. This is the standard size for the OpenMV cameras, and in the past they've used processors like the STM32H7. The N6 is certainly a step up in performance. So kind of like if you want the ultimate in their performance, the N6 is the one to go for. But the AE3 packs a hell of a punch, and it's in a 1-inch square package. So yeah, these are really cool. If you're interested in video processing, especially live, like analysis of the video, it's well worth a look at these cameras. Quabina is the co-founder, and he's been doing the rounds of. He's been on podcasts, and he's been releasing really interesting YouTube videos. They've also done some really good MicroPython integration, and with Damien's help. So the other benefit here is that both of these general processors will have they do all their work open source. So MicroPython will be extended with STM32N6 support and ALIF support for the Ensemble. But they also demonstrated some really interesting stuff with OpenAMP, because both of these chips are multi-core, and so they were able to define, like, one example that I was really interested in was that they defined like an async method, which was doing some machine learning algorithms, so detecting where people were in an image and whatnot. And then they decorated that method such that it instructed the framework to run it on the second core, and the second core was hardware accelerated. So it was just really elegant and actually really performant. So well worth watching Quabina's videos. He's got a YouTube channel. Their March newsletter has a link to all of his interviews that he's done, including this one that he had it was about an hour-long chat with Damien. So yeah, it was well worth a look at all of this. The Kickstarter was fully funded in a couple of days, and they're looking for an 80K goal. They're still accepting funding. The cameras, these are a little bit pricey for like the kinds of, I mean, I think they're actually quite cheap if you look at anything that's compared against, but you're looking at about 130 and 190 for the cameras, which for what they do, it's pretty much a bargain. But it's not the kind of thing. It's just for me, it's just above that price where I was just randomly buying one. But I did anyway. I've got the I got the AE3 just because I had to have it. And be aware they're not likely to be delivered until toward the end of the year. So yeah. Anyway,
is the custom silicon doing that stuff, or is it sort of a generic silicon, but they're doing similar instructions?
Yeah, that's more like it. That's right. Yeah. So it's mostly just designed to do the like tiny ML sort of acceleration. Yeah. but it's a lot faster. And the other thing in particular, they've targeted with the AE3 is it's really low power. So I think the AE3 compared to the H7, they were saying it's an order or two of magnitude faster with an order of magnitude less power, something in that order. It was pretty impressive. Yeah. Anyway, I'll move on. SparkFun was the other really interesting news. You can see this laid out, and I didn't realize at first that's the MicroPython logo that they've laid the boards out. Don't know how I missed that, but anyway. They announced a bit of new hardware, a couple of new red boards, which is their term for their development kits for Drop-Up Microcontroller, as well as a bunch of other, like all these boards are relatively new. But the cool thing for MicroPython was they announced support for 47 new libraries. So that covers a whole bunch of the boards that you can buy from SparkFun. They all now have libraries which are supported in Python and MicroPython, and they're all like pretty good quality. Like they've all got like good consistent documentation, good images, and they're all MIP installable. So it's going to make me look at the SparkFun stuff and see what I need to add to my rack of add to the collection. Yeah, exactly. But yeah, kudos to SparkFun. That's really good. They've also raised a couple of PRs recently in MicroPython to add some of these boards. So stay tuned if they're not already merged. They will be soon, likely. I don't think I actually had any hardware this month, which I think is a first for a long time. Anyway, it's probably a good thing. In general hardware news, STM recently announced their U3 series. Their U series is their ultra low power stuff. Previously, the U5 was sort of the king of the hill there for them. And the U5 is a little bit more powerful than the U3s, but the U3 is about twice as efficient as the U5s. And the U5s were no slouch to begin with. So these are excellent for super low power where you actually need quite a bit of grunt as well. So they're nearly 100 megahertz M33, plenty of RAM and flash, but also like tons of GPIO if you want to. I3C, they got all sorts of stuff in there. And for a low power device, this is pretty remarkable for the amount of grunt you can get. They are available now. The Nucleo has only come out in the last week or so, or at least they made available in the last week or so. Someone's in the chat. I should see. Oh, thanks, Scruss. So as a former SparkFun dealer, Scruss says they sell a lot of very neat things. So yeah, I'm glad of that hardware support too. Xiao, I'll just open up this link because it didn't get to do everything. Seed Studio have announced this 6-channel Wi-Fi 5-volt DC relay, so I didn't get that right. But it's basically designed to accept the Xiao and have relays attached. $20, not bad. Yay for more hardware. Silicon Labs had the BG29, which I've got a link here. Let's do that. This thing's pretty tiny, less than 3 mil square. Also pretty powerful, definitely grunty enough to run MicroPython. It doesn't yet, just to be clear, like Silicon Labs, we don't have a port for it yet. But this is actually designed to go onto people's teeth, was one of the use cases they're advertising. But it's a pretty powerful little guy, and it's got Bluetooth support, all the rest of it. So yeah, tiny little thing, and looking for medical purposes. Pretty interesting micro, so I thought that was worth sharing. Pi Cascades was in February, and one of the talks there was from Sage Elliott, who tried to convince everyone that they should build their own robots, and I think he did a pretty good job of doing that. He was talking about microcontrollers and microprocessors and using MicroPython to do all this. And it's a really engaging talk, well worth a watch if you're into that kind of hobby robotics stuff. XSK I've come across on Mastodon, where he was actually asking for help about trying to get faster performance for pin interactions on MicroPython. So I threw him, Damien, you're listening, I pointed him towards your old running fast and efficient MicroPython, because it's very similar to what you presented back at PyCon AU a number of years ago. And I also threw him a few other suggestions, and off he went. You can see this mess of stuff here. What he's trying to do is he's into retro computing, and so this is a Super NES, SNES cartridge, and he was trying to slurp the 4 meg data off of it. And so he was able to do that. His initial implementation wasn't the slowest one. It still took over 2 hours. But after twiddling around and playing with it, it's down to under 10 minutes now. And he thinks that it can go further, go faster as well. It turns out he was also getting some, you'd be unsurprised as electronics engineers, he was getting some errors in the data, and he was a little bit suspicious of his cabling. So he turns out that signal integrity was a problem, and he tidied it up with a custom PCB and still some wiring, but much less of it. So yeah, got rid of all the checks and errors that were plaguing him at the start. But yeah, a good little success story about iterating pretty quickly. He's published this on Mastodon. The links are there. You can see it. And he's just released actually like a repo of the comparisons of the different approaches, like using Viper and using register access and so on. So worth a look. I've got a link here, which I'll just quickly talk about. A while ago, Andrew and I'm sorry, Cal, but I always call you Cal Giggles because of your name. I'm not sure what your surname actually is, but you'll forever be known to me as Cal Giggles. But there was an effort from Andrew and I had a little bit of input into this, and from Carl about trying to get the LVGL bindings working more naturally as a user C module in MicroPython. Previously, it was kind of quite an awkward build system to get this running, and so this ticket had been open for quite a while and had a lot of discussion about it, but it was recently merged, so it's actually in a really good state now to take the next step, which is to package LVGL a little bit better for MicroPython, so it's easy to use for many devices. So this is just something that's we're trying to tick over whenever we get some spare time, because LVGL would be an excellent library to have MicroPython support for. Good step in the right direction. China Deveropu updated his pocket spectrometer. Also worth a quick look. It's at version 2 now, and he made a lot of improvements just around. That was actually his first iteration. The second one is much neater and much easier to assemble. And this thing can, take a look at some fluidy colors and figure out a spectrometer display from it. So yeah, pretty interesting little blob of hardware. It's got legitimate usefulness in chemistry applications. So everything's here is open source, including the 3D prints and the software and everything. So that's really cool. Did I close it? No. If you've got a tulip and want to add a battery to it, Andy had a great write-up on how he added it. It's very simple, but yeah, fits in nicely in the back of the tulip. For those that don't know what a tulip is, I have one here if you want to have a look at it. Awesome little device for playing with audio and driven from MicroPython. Thank you, Oliver. Sorry? I did talk about the simulator last month, yeah, which was really cool. Carlos Escobar, which I can't help but think that sounds like a drug baron's name, but Carlos, this is really cool. He has also another retro computing thing. The MSX is an old Japanese computing system, and basically gutted the Z80, which is the main processor out of this thing, and replaced it with a Raspberry Pi Pico and kept the rest of the system running. So you can have a look at how he did that. All the software is available. This is, I mean, that's an awesome screenshot, if you ask me. MicroPython for MSX. I haven't had a chance to dig into the software yet, but I believe it's all available. Yeah. So that might be one of the more interesting ports of MicroPython. Final thought. So that was all the basic news that I had. For those that haven't seen it, Animation versus Coding is Animation versus something is a series of YouTube videos designed by some, I presume, graphic designer, and he kind of explains a topic. There's a chemistry one, there's a physics one, by these really cool animations. And so this is talking about how to do coding and how the stick figure learns about coding, and then the computer kind of turns on him. And so the animation's really slick. It's really well written, really well done. And all of the code in it's actually legitimate Python code. And sort of by the end of it, he starts creating an LLM. Actually, that was all Pygame stuff. But yeah, it's well worth a watch. Have a look at it. Those in the MicroPython computing will know Peter Hinch. Someone posted on the MicroPython discussion boards that DeepSeek. This person was using DeepSeek to look into some MicroPython stuff, and it talked about Peter Hinch's amazing micro-stepping motor driver libraries that don't exist at all. so I thought that was really funny. So Peter's response is funny too. How deeply bizarre. Anyway, worth the chuckle. Sorry.
Stuff that you don't know
I thought this was funny too. I stumbled over this. It was in IntelliSense. Someone had written button, ready button, and then the second button that it suggested was righty button. Instead of cancel button or something, it's righty button. And that's it. And this is this is the what's it called, Midjourney image in honor of OpenMV's snakes taking photos of stuff. And that's it. Any questions? Any comments?
Great, Matt. Thanks.
Did you have anything to add about the OpenMV stuff? Because I know you've spent a lot of time with Corbina on that. So
the interview I did with Corbina, yeah, it's I think it's quite interesting. It touches on a few new topics. The Aleph chip is definitely a very interesting new microcontroller. It'll be good when we have support for that in mainline MicroPython, which should be very, very soon. It's kind of like an ST part. It's very professional and has lots of peripherals. Quite sophisticated part. Good low power support, heaps of power domains within it. Multi-core, these ethos co-processors from machine learning. Yeah, pretty interesting part. And they're not expensive either, 8 Aleph chips. I mean, they're not like, they're of order T parts.
I was going to write some of the specs, but I didn't get around to it. And there was already a ton of stuff to talk about with OpenMV. But the Aleph's got 15 meg of RAM?
No, it runs at 400 megahertz, and it has 5.5 meg of RAM.
5.5, okay.
Or is it 5.5 meg of flash? One of them.
I thought it actually had like 15 meg of RAM and 5 meg of flash, but I could be wrong. Unless they've added it in OpenMV, I'm not sure. But, I could probably check that. We have the technology.
Yeah. 4, 5, 6, 7, 8, 9, 10. Yeah, you might be right. Yeah, 5.5 megabytes of MRAM, and then quite a lot of SRAM.
Yeah, and so one of the tickets that Corbina had been working on was to try to get the some form of split memory stuff going on here, because the garbage collector was taking a long time to walk through the large amount of memory. So I think that's something he talked about in one of his videos anyway. Don't know if that's up yet, but
yep.
But the other chips, like you can see, there's some quite interesting chips that they've got. Triple core, quad core, all pretty low power for the kinds of things that they're doing. A little bit frustratingly, you can only seem to get an evaluation board for the E7, and it's quite expensive. It's about $300. It's not terribly expensive for what it is. It's just that it's a lot more than I'd want to play with, to be honest.
Yeah.
Pretty interesting. And for reference, there's a Nucleo for the N6, and that costs about 100 Australian. So not the cheapest of chips, but they are super powerful. Yeah. Actually, there's another little joke I didn't include, but C and Python, this might tickle those of us who know C and Python well. This is both C and Python code. I'll let you pick that apart. And on that note, I'll stop talking.